All right. A very warm welcome to all our audience today. Thank you very much for joining us today on this webinar. We at Impetus Technologies are delighted to bring this webinar to you, where we will be talking about how to future-proof your StreamAnalytix architecture. Now, I'm Pankaj Bagzai, Marketing Manager at Impetus Technologies, and I'll be your host for today's session. This webinar is being delivered as our continuous effort to create leapfrogging advantages for our customers and to advance the marketplace of cutting-edge big data solutions. So without further delay, a very brief introduction of our speakers today. We have joining us today Anand Venugopal, the Senior Director for our product StreamAnalytix. Anand has been working with Fortune 1000 enterprises to deliver real business benefits and ROI from big data solutions since 5+ years at Impetus. And prior to that, since 1995, has been in techno-business evangelism roles in various industries, including telecom, gaming, media, and entertainment, and high tech. Also joining us today is our guest speaker for today, Mike Gualtieri from Forrester. He's a principal analyst with Forrester Research Inc., and we are pleased to have him as our guest speaker today. So without further delay, Anand, over to you.
Thank you very much, Pankaj, and a big hello to our audience. Whether you're listening live or to the recording of this webinar, this is Anand Venugopal, your co-host with Pankaj Bagzai, and the product head for StreamAnalytix at Impetus. And it's a delight to have with us one of the luminaries of the big data world, Mike Gualtieri, who's been acknowledged widely as one of the leading influencers of the big data ecosystem itself. We have a really interesting webinar today coming up for you, Future-Proofing Your StreamAnalytix Architecture. Mike's going to share a lot of valuable information, and then we'll also touch upon some material from Impetus. First of all, let me just introduce to you Impetus. Impetus Technologies has been around since 1996. We've been providing mission-critical technology solutions to large enterprises and technology companies ever since, both in North America and world over. And some of the global leaders that everybody recognizes in the world are our clients, and we've been having the privilege of doing real big data implementations at these large financial services, telecom, healthcare, retail customers. And in that journey, we have learned a bunch of very important lessons, and some of those lessons end up being a need for products that fill an open space. And so that's what has taken us from being a services company to now we are a very uniquely positioned products and services company in the big data world. And the StreamAnalytix, one of the products of Impetus today is the focus area here. We have 1,600 people or so, approximately between our U.S. and India locations. The company is headquartered in the U.S. in Los Gatos, California. So feel free to engage with us offline and write to us at the inquiry, and we'll show you the email IDs, etc. towards the end. So that's Impetus, the company that's bringing you and hosting this webinar. A quick view of the agenda today. We have Mike covering the business need for StreamAnalytix. We have Mike covering the first 4 or 5 bullets: technology overview, use cases, architecture blueprint, and a very interesting comparison of all the different streaming analytics platform options today. And then towards the end, I will also cover what is the unique approach that StreamAnalytix brings and how does it fit in with what Mike's going to share with you today. Okay, so that's the quick view of the agenda. And over to Mike Gualtieri.
Anand, thank you very much, and welcome everyone. My name is Mike Gualtieri, Principal Analyst at Forrester, and I cover big data technology platforms, including StreamAnalytix. First thing I thought I'd start off with is that, we don't do technology for technology's sake, right? There's some priorities, especially some business priorities behind them. And we recently surveyed about 3,000 global decision makers to ask them what the top business priority is over the next 12 months. And I guess it's not too surprising, right? They want to improve the experience of your customers and improve those products and services, because if you can do that, you can retain customers, you can grow your customer base, you can create more loyalty. And when we look at what that actually means and why that's become a priority, just a quick history of personalized experiences. Way back when, you'd walk into a shop and the shop owner knew who you were and probably knew what you needed and was already grabbing it from the shelf. We had extremely personal relationships. But as the world scaled, as we got global companies, we went more to mass production. The customer experience went down. We tried to get back to that with customer relationship management systems through segments. And now we're at a point where we have big data and the technologies to create very hyper-personalized, real-time digital experiences. So that's what companies are trying to do. At Forrester, we call this the age of the customer. And I just net that out, and I call it celebrity. Customers want and increasingly expect to be treated like celebrities. George Clooney walks into a restaurant, you're not just going to give him any old menu that everyone gets. It's going to be very customized and personalized. And so what companies want to do is they want to create experiences that are individualized and more personalized. And that's what's behind the momentum for streaming analytics. So I just call these celebrity experiences. But to do it, you have to use analytics to learn about the customers. All right, we might know something about George Clooney, but do we know something? Do we know enough about our 1 million customers to serve them individually? Do we know enough about their behavior? We also need to detect in real time what their situation is, because what they need in that moment is often based upon the in-the-moment situation. And then we need to develop applications that can adapt to serve that individual customer. So that's what's behind this trend. And analytics, real-time context, and adaptive applications, it taxes existing approaches to application development. And all of these experiences, you can add all of these capabilities, but it has to be blazing fast. You have to be able to do this in real time, and you can't have the architectural concerns associated with that. Now, another key enabler of this trend is big data. And many people think of big data like stored in Hadoop after the fact. But the fact is, all data starts out as fast data. It's all data starts out as real-time data. And it's transactional data, it's usage, it's behavior, it's IoT data, it's social media data. It's all data. And it always starts out fast, and it's often used analytically after it becomes big data at rest. But that's not good enough to create these modern apps, to create these celebrity experiences. We need analytics not just after the fact, but we need 3 key types of analytics. Sure enough, we do need those historical analytics, the traditional BI, the at-rest analytics. But to build these types of apps, we also need streaming analytics and we need predictive analytics. We need the streaming analytics to detect patterns, events in real time. We need the predictive analytics to know what to do about it. And together, these constitute advanced analytics. And the streaming part of this is among one of the hottest advanced analytics technology. You can see from this survey a comparison between 2014 and 2015 that there's increases in all of these advanced analytics categories. But what's really interesting about this data is look at the maximums, about 42, 48% for predictive. What that means is that half the companies aren't using these technologies. That's actually good for you, because that gives you a competitive advantage, okay? If you start adopting and creating these type of applications now, you will be, many of your competitors will not be. So a lot of people get tripped up on this whole real time, like what is real time? For the purposes of this conversation, real time means business time. So real-time means different things depending upon what the context is. So if a customer walks into a shopping mall, if you want to detect that event, okay, that's maybe a sub-second or maybe a multiple-second event, right? So for that event, that's what real-time means. A shopper clicks on an online ad, that might be in the range of some number of milliseconds. Stock price, that may be very, very low latency. That may be very near real time. Customer uses a credit card, sub-second. Customer wakes up, it may be a few minutes. So, whenever I talk about real time, it has to be contextualized in the situation that we're detecting. StreamAnalytix handles all these situations, and most companies, more than 50% of them, aren't really capturing the value in streaming data. So I want to talk to you about how you can capture that value and what are some of the platforms that enable this. So the simple way to think about StreamAnalytix is that it's blazing fast ingestion, analysis, and then it can act on that data. And it can do this with multiple sources of fast data. Right? Now the key here is that it's all three of these. It's not just about ingestion. It's not just about analysis. It's not just about actions. Together, those are the capabilities that constitute a streaming platform. So our official definition is StreamAnalytix platforms filter, aggregate, enrich, and analyze a high throughput of data from disparate live data sources. So that's multiple types of data sources. And they identify patterns. They detect those situations. And they automate those actions. And in this case, that translates to being able to create a whole new class of adaptive applications that serve individual customers. Now, thinking in streams is very different from traditional historical analytics. There are notions of filtering, aggregation, enriching the stream. Say, part of your stream is a location data with lat longs. Well, is there an event occurring at that lat long? What's the address at that lat long? So that's what enrichment means. But stream also has time windows, right? Because real time means temporal. It means there's something happening in a certain window of time. So if you think nothing else about StreamAnalytix, understand that a time window is an essential capability, and it's a unique capability of StreamAnalytix. It's what separates it from traditional analytics. It's what separates it from predictive analytics. So all of these capabilities will give your application a real-time capability. A couple of examples: telematics from sensors on board cars. Those can be used to predict part failures. They can also be used to detect slippage in a wheel and then notify people 2 miles back that maybe there's slippery conditions. Certainly mobile apps are absolutely very contextual devices, right? Not just because they have location, but they have accelerometer. There's lots of interaction from the user. Real-time location analytics or real-time other real-time sensory data can be used to create those adaptive apps. Even farmers, where customers of equipment can analyze IoT data in real time to reduce maintenance costs, increase the uptime, or even a flash sale online retailer can continuously monitor customer behavior, not monitor it yesterday, but monitor it right now continuously to change those prices and change the catalog in real time. So whatever business you're in, there's some real-time component or there's some real-time opportunity. And consider this final example: every button pressed on that remote control goes back to the cable company. And what if they could detect who's watching, right? Because in a household, you might have parents, you might have kids. What if they could detect, based upon the keystrokes and the time of day and a lot of other data in real time, who's watching? If they could do that, they could serve a very relevant ad to whoever's watching that TV. So again, I encourage you to think in your business, your domain, where real time has an impact. What does the architecture look like? Because it's not a conventional architecture. A conventional architecture for applications is very request and response, isn't it? Like, you develop this application, and there's menus, and there's forms to fill out, or information to see, or things to swipe and click, and then there's a response back. Well, streaming is very different. You have all that, and in fact, some of that is a real-time data source, but there's other sources that can be combined, and that's your streaming data from all your real-time sources. You need to be able to ingest that information at scale and then do your streaming analytics And from that streaming analytics, you're going to find those opportunities, those perishable insights, we call them. And we call them perishable insights because you have to act on them. You have a certain amount of time to act on them. Otherwise, it doesn't matter anymore, right? But if you can capture those with streaming analytics, then you can create this whole new class of what I've been calling celebrity experiences or celebrity applications. Now, sure enough, that same data that's coming through that real-time pipeline also goes to data at rest, analytical storage, because that's where you're going to do your predictive modeling to determine what actions you're going to take when that streaming comes in. So it all works together, and then, of course, you learn. There's a learning loop here from the streaming data that makes those models even better over time. So you start learning about customers. You learn about the use of those applications so that they can be continuously improved. Some people call this the Lambda architecture, where there's a speed layer at the top, and then there's the batch layer at the bottom. But together, this is the architecture you need. Now, when you have this architecture and when you have a streaming platform, because this is not easy to do, to ingest and to do those analytics, what it does is it frees you up architecturally from these non-functional requirements. So if you're trying to design a real-time app, scale should not limit your design decisions. You should not have to say, oh, well, we can't do that because we wouldn't be able to scale. These are real-time systems, okay? Whenever you hear the word analytics, normally you think, all right, we're doing some sleepy analytics, we're writing some reports, we're doing some SQL workloads or something, and then we get the answer later. Nope. Streaming analytics, we need the answer now. So another characteristic of streaming platforms is that they're highly available, okay, because they become part of the application. And they don't work in a vacuum. The streaming platforms have to fit and work seamlessly in with existing architectures, especially for a large enterprise. And they have to accommodate both analytical and transactional streams of data. It's very common for people to say, oh, streaming analytics, let's see what the Twitter feed is. That's only one source. Or IoT, that's just one source. Streaming platforms also have to be able to ingest transactional streams of data along with all of these other sources as well. And they also have to have the horsepower to perform real-time analytics. And I cannot emphasize this enough. The architecture, the topology of the streaming platform has to be flexible enough to also provide the compute horsepower. Because remember, streaming analytics is not just about ingestion. In many ways, that's the easy part. It's the analytics that makes it much more complex. And once you incorporate a streaming platform into your application architecture, it totally reduces those architectural concerns of scale, of performance, and frees you up to actually develop real-time applications without spending 80% of your time figuring out how to do it in real time. That's why streaming analytics platforms are popular. So when you're shopping for a streaming analytics platform or technology, there's a few key requirements to keep in mind. Of course, one of them is the architecture. What are your runtime deployment options? What operating systems can you deploy this on? Can you deploy it in the cloud? Performance and scalability. Again, inherent in the design of streaming analytics platforms is performance and scalability, but the different platforms have different approaches to this, right? So you have to look at this. You have to have high availability and disaster recovery. High availability within one cluster is cool, but what if the data center goes out? Can you do WAN? Can you do active-active to another data center? Setup management and monitoring tools, security, data sources. What sort of data sources can this handle, both input and output? And then the development tools, because don't think of a streaming analytics platform as just an engine, right? It is a platform to develop streaming applications. So what sort of professional development? Are there any business tools? Because some people use streaming analytics platforms to create real-time dashboards, and some of these tools actually offer a drag-and-drop interface that allows business people to actually do, to create these types of dashboards. And you also need debugging, testing, and simulation. Any of the tool sets that you would need for regular application development need to go along with streaming, but they have to be specific for streaming. Now look, this is the heart of the streaming analytics, and this is what separates streaming analytics from just ingestion platforms and other types of messaging platforms, and it's the operators. Okay, this is all about the analytics. And you have to be able to filter, aggregate, do location-based, of course, time windows, temporal patterns, all of the things you see listed here. These are the analytics, and these have to be built in, or they should be built in. There's some platforms out there that basically give you, a framework, and they say, all right, you want an analytical operator, you can code it here, right? And certainly that's a feature you want, but you have to have these streaming operators. This is indeed what separates streaming analytics from other platforms. So let's look at some of the solutions, or the categories of solutions. Be careful not to confuse streaming analytics with related or complementary technologies. So I've made a big point already that it's not just ingestion technologies. I mean, ingestion technologies do connections and routing, and they're very complementary. Many of the streaming platforms have their own ingestion technologies, but by definition, they have to work with other ingestion technologies. So, a message bus, some sort of database connectors. These are ingestion technologies, but they're not streaming analytics technologies. ETL often transforms data from multiple sources. It's not real time, right? That information is, targeting data at rest. And even if you take the data into Hadoop, for example, and then process it there, it's just not real time, right? So it's not ETL, but streaming analytics platforms do have transformation, right? You necessarily have to prepare the data, but you have to do it in real time, so it's not ETL. Now, complex event processing is interesting, better known as CEP. CEP engines are a feature of some streaming analytics platform, and it's really about low latency pattern detection. And many CEP platforms are absolutely streaming analytics platforms, but sometimes streaming analytics platforms don't have this capability. So just, if you need this capability, you have to understand what it is and make sure that the platform has that. Real-time dashboards, that is not streaming analytics. That is a way to view the results and the analysis of streaming analytics platforms. But again, that's not streaming analytics. And some people think that microservices are streaming analytics, but those are simple stateless events. And think about it. I mean, we don't have time to get into the details of time windows and temporal processing, but think about it. It can't be stateless, right? Because if you're looking for a pattern, a complex pattern in time, it's not about a simple event occurring. It's about a sequence of events occurring from potentially multiple sources. So by definition, that is stateful. Okay, so microservices can be used for, simple events that occur. Event occurs, action taken. Okay, but they're stateless, so it's, don't confuse it with streaming analytics. And then, of course, there's many packages that have packaged software solutions that do real-time ingestion and analysis of data, but those are embedded in software like manufacturing control systems. Now, when we look at the actual streaming analytics platforms and the categories market, it's a very dynamic market. The reason for that is everything I said at the beginning of this presentation. The momentum for streaming analytics, the capabilities it can provide to provide that celebrity experiences. And the big enterprise software vendors have proven industrial strength solutions that include enterprise integration and tooling, which is very important for application development, and many of them also have the CEP capability. Enterprise software vendors are known to charge more, to charge a premium, and sometimes the feature richness and how long these platforms have been around creates some complexity in the implementation. There's a ton of open source streaming projects out there, Storm, and there's other micro-batching solutions like Spark Streaming and others, it's free to use. So it's certainly easy to adopt from that standpoint. But there's also an increasing number of projects to choose from. They often lack enterprise development and management tools, and this is very common, right, in the open source community, and that's why you have commercial companies that often add these enterprise features to the open source. But one of the things that's interesting about the streaming is that there isn't really a community consensus necessarily of what products, what streaming projects are sort of the go-to project. I'd certainly say Storm is probably high on that list, but there's so many other projects coming out, it's often confusing as to which one should I pick, you know. There's a handful of streaming analytics startups that's driven by the trends I told you about. It's also driven by IoT. They are very purpose-built for today's diverse streaming analytics apps, and they often leverage open source with some enterprise tooling. The con is that it's still very early in the cycle to predict, you know, who's going to adopt these solutions and which ones will come out on top. And then finally, there's some cloud exclusive streaming analytics services. It's quite interesting. A couple of years ago, Amazon, the most highly adopted cloud platform, came out with Amazon Kinesis. Microsoft followed with Microsoft Stream. So you've got a pay-per-use model. It's certainly integrated with other cloud services. The cons are that they often provide only a limited analytical operator. So there's key operators I told you about. So there's a lot of programming, and they lack an on-premise solution if you need that as well. So that's sort of a breakdown of what some of the choices are. Probably the way you should think about this is to figure out how to abstract the streaming analytics capabilities. Because really what we're, the net of our presentation here is how can you future-proof a streaming analytics solution? How can you choose a solution? And often what sophisticated application development groups do is that they abstract that. So you've got streaming data, and you need these 5 capabilities. You need to be able to ingest. You need to be able to prepare. You have to analyze. That's the heart of it. Decide and then act, either sending out messages, alerts, or taking actions directly in applications. And I'm going to hand this over to Anand, who is going to talk about StreamAnalytix approach to abstracting these capabilities. Anand?
Thank you very much, Mike. Great set of insights, and I'm sure the audience is all over everything you said. And I'm going to recall a lot of what Mike just shared with us in relevant points in my piece here. So as we just saw, there are a variety of different options for streaming analytics. Primarily, it is enterprise OEMs and open source projects, and there's obviously big advantages in both. And of course, there are smaller proprietary startups as well, which offer obviously very credible products. But here's the issue, right? There are disadvantages with each option. Enterprise class is too expensive. They're probably less flexible, not fast enough to move and innovate. There may be small, hot startups who may not exist or who might get just picked up by one of the big companies, etc. So there are a number of different disadvantages in each of those different options, and including open source, doing it yourself. There's the disadvantage of having to invest a lot of your own resources to keep track of that particular technology, ensure that all the system integration is done. It can typically take many, as long as a year and a half by the time you get a full-fledged platform built out all by yourself, even though there's open source components available, right? So but you do want to obviously leverage the community ecosystem of innovation and the new set of projects that keeps coming along once every year or two. And so you really want access to the open source community and open source technologies. and make that part of your core engine. But you also want enterprise class. If you're an enterprise, you really don't want to be, you want to really one neck to choke, so to speak, and one vendor who's accountable to support the product and ensure that all the enterprise-grade needs of reliability, manageability, services, etc., is addressed. So StreamAnalytix brings to you the combination of both of those. And like Mike addressed, a platform needs to abstract multiple functionalities. So the core functionalities in streaming analytics is ingest, filtration, pre-processing, complex event processing, actual analytics, both predictive analytics, running predictive models, complex or sophisticated analytical models, as well as just basic statistical and arithmetic operations connected to a live dashboard, things like that. So all of those important critical components, and then there's also another important piece that Mike talked about, which is being able to connect an event or an analytical result to an actual action so that you can literally take action based on the immediate insight that was derived. So all of those logical components are abstracted, packaged together, integrated in StreamAnalytix, and that's what the Streaming Analytics platform does. And here you have the benefit of both enterprise class and open source. So the other key point is abstraction of technologies. Given that there are so many technologies emerging, Apache Storm has been one of the leading technologies in the last 2 to 3 years, or last probably a little more. And now there's a Spark streaming coming up. Everybody's jumping on the Spark streaming bandwagon, clearly. So as an enterprise, what you want is not to be blindsided by this innovation or to become obsolete in your platform that you choose become redundant and obsolete in your enterprise just next year. What you want is being able to leverage the next great technology that comes out after it is ready enough to be deployed. So if you, let's say, ran Storm in the last couple of years, what you might want to do is when, somebody just mentioned in the chat that, Twitter's using Heron now, and they discovered that at the next level of scale that they're at, they want they want more from Storm, and they made Heron backward compatible with Storm, and they've not, of course, open sourced it. But sitting there as a Storm user, for example, you might want to say, gee, I wish I could just upgrade to Heron. How would you do that if you did it all by yourself, right? That's the exact problem that we want to solve for you. So we abstract these technologies under the StreamAnalytix platform. There's an IDE which helps you to build applications, engage with applications independent of the technology. And you can just push down the details of the streaming engine, and the platform does that abstraction for you. So today we have Apache Storm. Soon we have Spark streaming support. And our promise is that we will keep bringing to the enterprise the most enterprise-grade latest technologies under the abstraction of StreamAnalytix. Okay, so that's the whole key point of abstraction of technologies under StreamAnalytix. So I want to quickly also put myself in your shoes and wonder what questions you might be having, right, as an enterprise buyer. First of all, you really want to answer the question why streaming at all, that Mike already answered pretty well. I just want to add one more point to that, and then you might have a question: build versus buy. Should I build? Should I buy? And then what to buy? And there's again, we saw some of it, and I'm going to rehash that, and from whom to buy and what to watch out for. So why streaming? Let me first deal with why the build versus buy. I'm going to go to the next slide. So the build versus buy option is a very important question. So many enterprise customers I've seen say, look, I've got really sharp guys. Why should I build? Why should I buy anything? Why don't I just build it? It takes a long time, folks. It really takes a long time to bring production-grade platform to the enterprise so that you can actually expose it to your users, have mission-critical reliability and high availability, performance tuning, integration of all the components, ensuring that everything is compatible, and then when somebody upgrades some piece, being connected to the ecosystem and being able to do that. So it takes a lot of engineering work, and if your software engineering is not your core business, if your core business is financial services or telecom, you're obviously more concerned about your business logic and running your business and building your application. And that's the whole reason why we have streaming analytics platforms. It might have been a valid question, much more valid question back in 2013 or 14 beginning to ask build versus buy. But right now, you already have the advantage of these streaming analytics platforms, including ours, having invested, built out to the latest and greatest requirements. So you might as well buy one of the options in the marketplace than build yourself. So the next question is what to buy, right? So before we go there, I just want to touch upon a few things and rehash that. So customer-aware, context-aware customer experiences is what delivers value, and that's why you have streaming in the first place. And the other thing we're seeing is batch versus real-time. There's a number of large customers wanting to move forward on their batch processes, compressing the timeline of days and weeks between sensing and analyzing and acting to seconds or milliseconds. That's what you see here in this slide. And the other thing is from the architectural principle from our side that we have adopted is really to give you the blend of both batch and real-time. So here in this slide, what you have is Hadoop works great on the left side, which is not so real-time, and the real-time analytics system works for the last few seconds or minutes of data, and you get able to blend both of those for insights. You have this Lambda architecture picture, again, that we have implemented in many use cases with StreamAnalytix. You have data coming in historically only to the batch layer. It's now going to directly fork into the speed layer and the batch layer. And then eventually on the right side, you have the merge of both the batch and the speed to give you the intelligent insights so that you can find out what the customer did just a few seconds ago in addition to the overall historical profile of the customer, for example, right? And there's also important connectivity and interactions between the two, which is the speed layer and the batch layer. So you might have a model that's being computed on the batch layer that's doing a recommendation engine type model or a propensity to buy, etc. And you can now put that model onto the speed layer so we can actually keep deploying and updating the models in real time. So that's the Lambda architecture that we have implemented using StreamAnalytix in many solutions. Now, another important piece is whether any particular technology that you buy fits in with your current technology environment, right? Nothing can be seen as an island. So today, you probably have Teradata, Oracle, traditional and analytical and transactional data warehouses. You have an elaborate data infrastructure. How does a new system fit into that, right? And that we're very sensitive to that on the StreamAnalytix side. And in this architecture, on the top layer, the real-time applications is where StreamAnalytix would fit in. And you most likely have some sort of Hadoop project or Hadoop initiative going on. That's what on the right. That's what you see on the right side in the center, right? You have the landing and ingestion zone, all the data sources on the left, coming in parallel to the real-time and landing ingestion zone, landing in the traditional data repositories and also into Hadoop. And the real-time feed, again, on the real-time application layer, gets a direct feed as well as is able to write and read from the traditional data repositories as well as Hadoop. And again, on the right side, you can merge the two into dashboards and visualization. And it's very important on the bottom side of the picture here that everything that you do and deploy obviously gets the same treatment in terms of governance, in terms of security, in terms of data lineage. So we want to we very consciously bring all of those disciplines to any system we build with our product and platform. So you obviously need the security, need the governance, and we will wrap that all as part of the solutions and the services around StreamAnalytix. So coming to the core of StreamAnalytix and how it looks and how we have abstracted all of these technologies, here's a nice block diagram of what we offer. The golden brown components are all StreamAnalytix software, and everything else in different colors are, third-party software, right? So the core of it is right there in the center. It says StreamAnalytix real-time streaming platform, and the admin UI on the top left. What that gives you is an environment to drag and drop different operators, like Mike was mentioning. Hey, you have different data sources. You have data processing operators. We have channels, so you can drag and drop, like let's say a Kafka spout or a RabbitMQ spout, as far as Storm is concerned, and then similarly for on the Spark streaming side. So you can drag and drop elements and create a nice data pipeline. And today there is the ability to deploy to Storm, and some of these technologies may be sitting on Yarn, or they may be sitting on by themselves. So we can either have this platform running on top of Yarn or on directly on hardware or virtualized hardware. There are applications on the right side that are essentially these workflows that you build visually, and you can drag and drop all of these operators. For example, like I said, the channels and the stream processing, the stream ingest operators. So you have ready-made operators to do data filtering, to do time windows for CEP, and for doing visualization, for writing into the database, for writing into the index. All of those are ready-made functions, and we have a variety of direct analytical libraries as well that we're coming up with in version 1.2 of the product very soon. So this product is GA. It went GA in earlier this year in February, and we have a major version coming up called 1.2, where you're actually able to build your own custom operators, custom libraries, and add it to the library. And there's versioning of real-time pipelines. So we have completely conceived an entire development environment where developers are building real-time applications. There's multiple versions of it, etc. So we're supporting the development environment of real-time applications as well as the operational environment, where once you deploy a product, deploy an application onto the real-time platform, you want to see it operational. You want to see how it's working. You want to see whether it is operating at scale or if there's any performance bottlenecks. You want to be able to add hardware or add capacity dynamically based on any bottlenecks or based on any latencies or throughput issues that you're seeing. So we make it very, very powerful for both the developer as well as the operations perspective to run your real-time applications. And the key point here on terms of abstraction is that we're building, this is an architecture that supports you to build applications and then deploy to Storm, deploy to Spark Streaming, deploy to the next available technology. But the first one is Storm, the second one is Spark Streaming, and we're obviously committed to continue to add more. And there's a question about Apache Flink, whether we are planning on that or not. There's not a commitment that's already been declared internally, but we will take that into consideration. So moving forward, I think, so we are actually at about the 45-minute time mark, and I want to run a poll, and Pankaj, why don't you speak to the audience about the poll?
Sure, thank you, Anand. So the poll is right now displaying on the audience screen. We would like to know from our audience if there is an architecture that offers functional and technology abstraction for streaming analytics with the required scale and performance that is attractive. So with the required scale, is that an attractive option for evaluation to you? Please respond to the poll in the WebEx window on your screen.
So you can click on A or B in the poll on the bottom right of the window. We'll give you a few seconds for that. We're really trying to get you all to weigh in your opinion and see what makes a difference for you, see if you're engaged with the ecosystem and if you've thought through these things and if this is important to you or not. So we welcome your feedback. Thank you so much for taking that little time.
All right, we'll just take a few more seconds while the results come in.
let me address one question in the meanwhile. So I think we have a question that says, I guess many companies are struggling with the use cases of big data technologies in terms of streaming data analytics. What use cases are identified and how to go about identifying use cases in each company, including ROI aspects. Thankfully, Impetus is a services and solutions company. We actually do help in identifying use cases and in fact, doing ROI analysis as well. So please contact us, and we will be able to help you with that. And of course, the use cases for streaming are a variety, including multiple verticals: financial services, telecom, e-commerce, ad tech. We've seen utilities in terms of oil and gas companies. We've seen a variety of use cases across the industry ecosystem, and Mike also covered some of that in his presentation. Are we ready to talk about the poll results?
Yes, definitely. So thank you for the people who have voted. So we have about 2/3 of the people, about 65% of the people who have responded to the poll who are interested in such an option, and about 1/3 people who are not necessarily interested with this option. So thank you very much, and hopefully you'll benefit from the content today and the value that we are bringing from this. So thank you very much.
So I want to address one last question, which is, from whom to buy, right? Before going into the Q&A portion. So you have large companies. We've talked about that, and you have smallish companies that are 20, 30 people, hot startups that are highly driven by VCs. They eventually get very steered in their direction by the VC who's actually funding them, and often might not be independent enough to make their decisions because they have a financial dependency. So Impetus is a great combination of stability of the large companies, because we've been around for 20 years nearly, and we've already proved that a stable, ongoing concern. And we have been working with the largest names in the world, the top 2 credit card brands, the top bank in the country, in the U.S., one of the top tier 1 telcos has adopted us, and from a both product and solutions perspective. There's a #1 healthcare company that's using us. So there's enough exposure to the enterprise world to know that space. And we're right size in terms of we're much more agile than very large companies. And there's a huge services angle to this, which makes the solution successful, and not just somebody wants to sell you a product and walk away, right? That's the very important piece that we have seen differentiating us in many engagements where we go in with StreamAnalytix. The customer wants the platform, and then they also want to build out a product. They want to build those UIs. They want to ensure that the full visibility to the management with the business interface, et cetera, is provided. And that's what we provide. In many cases, that's done in such a rapid manner that within 4 to 6 weeks of us being on the ground, we've actually built out 8 to 10 different use cases and delivered the whole solution. So that's actually happened in both the success stories that I wanted to talk about. One is the hosted call center solution, and another one is a tier 1 telco. And in both cases, we delivered a very, very business critical solution in the course of 6 to 8 weeks with StreamAnalytix, and the customer continues to work with us, build out many, many use cases. So with that, I think I'd like to go to the questions part of our webinar, and here are some details for you to. First of all, you keep your questions coming. We're going to start addressing them also now, and write to us at inquiry@streamanalytix.com, and www.streamanalytix.com is of course available on the web, and we will be live in front of you all at the Strata Hadoop World in New York in September. So definitely come by, meet us there, or engage with us on the web and by email. Okay. So over to Pankaj. You want to ask some questions and you want to address it to us?
Sure, definitely. So one of the questions that we have is somebody needs to know when you said about real-time analytics, are you talking about fitting the model in real time, for example, doing a logistic regression or a neural net, or are you applying the parameters of an already fitted model that has been fitted in some batch?
Sure. I can take a crack at that, and then Mike, you can also respond.
Yeah.
Let me repeat the question again. When you say real-time analytics, are you fitting the model in real time? For example, doing a logistic regression or a neural net, or are you applying the parameters of an already fitted model that has been fitted in some batch? Both are possible in as far as real-time streaming analytics is concerned, but I think many models that apply in a batch context may not apply in real-time streaming. So in terms of what's possible, both are possible. And what we mean is things like anomaly detection, things like fraud detection, things like predictive maintenance, where you're detecting a pattern of failure, things like that, which do require real-time analytics and real-time scoring, is more of the use cases that I've been referring to or I'm talking about. Mike, over to you if you want to address that.
Yeah, no, I think that's right. I mean, I think that most of the predictive models that you're going to use to score later on, that would be done offline. There certainly are types of models that can be scored continuously, like certain Bayes algorithms that can learn continuously. That's not really what we're talking about here. We're talking about, a more likely use case is that some interesting pattern, contextual pattern is detected, and then you want to figure out, all right, what to do about it. And often at that decision stage, remember those 5 pillars I laid out? At that decision stage, you may enrich or you may call a model to get a score or to get an action or a prediction to figure out then what to do with that action. So that's how these things work in conjunction. So, the use case for streaming analytics is always temporal. The core use case is I'm looking at something in a time window that's interesting. So it's not really an engine for, building models. It definitely can do that, but that's not sort of the key use case.
Thank you, Mike. Here's another question that we just got. How can we plug into StreamAnalytix from our existing platforms? Do you provide API service on the product also? And what language or infrastructure is required? So from an application layer, there's a number of interfaces to StreamAnalytix. We do provide a REST API, and I'm not sure what you mean by your existing platform. So it is made open to be able to interface with an application layer, and so it is pluggable. The StreamAnalytix platform is pluggable from above using APIs, and we can definitely engage in more detail to understand exactly what you mean. And Java is probably the most convenient language to use StreamAnalytix with. And in terms of infrastructure, there's no additional special infrastructure required. It's basically commodity servers, running virtual machines, and Linux operating systems, different flavors of Linux operating systems work. So, Pankaj, is there any other question?
Yeah, sure, definitely. So one of our audience wants to know, and actually says that many companies seem to be struggling with use cases that involve big data technologies. So in terms of streaming data analytics, so what use cases are identified and how can one go about identifying the use cases in each company, including the ROI aspects?
Yeah, I briefly dealt with that. We do have a full-fledged consulting services that would help you with identifying those. But what I can share now is that the kind of interesting use cases we're doing is there's a lot of pull from the telecom sector on this. We've seen cases where we want to provide for one of our customers. We are stitching together call logs from different boxes or servers across the internet and providing a real-time visibility for call center analytics in what is exactly happening in that call. When did the agent get on? when did the agent get off, and which part of the call was there an error in? So that's a hosted call center solution for doing for performance analytics for in a call center situation. In another case, we are receiving live set-top box data, looking at and predicting what a frustration score of a customer could be when they call into the call center by correlating whether their set-top box has an error in real time and whether this particular customer has opened a maintenance ticket, and having all of that information correlated, blended, and available to the call center agent when the call comes in. So those are some very interesting use cases that we have done. In addition to, of course, ad tech, there's a very large company that's looking at, scoring a cookie. And here's another thing that I wanted to mention. Not all streaming platforms are the same, right? With things like Storm, which are based on discrete event processing, you can do very, very low latency use cases. Whereas in a micro batch situation, you can only do the least latency you can turn around with is about 500 milliseconds. So in the case of ad tech, when you need about 20, 30 millisecond turnaround time, you need really a discrete event processing system to do that. And then Storm, of course, does that today. And there are probably other systems that do that as well. There's a question about, I tried to answer it when I was actually delivering itself because I saw the question coming in. Is there a hard dependency on yarn? And how do you create a common abstraction over both a tuple at a time and microbatch computational frameworks? Great question. We have obviously figured this out, otherwise we wouldn't be, so there are two questions there. Is there a hard dependency on yarn? No. We can work with the streaming technology on top of yarn. So you could have Storm on yarn, you could have Spark streaming on yarn, and our platform riding on top of that. Or we could directly write on virtual machines and hardware, like I said before. How do you create a common abstraction over both a tuple at a time and a microbatch computational framework? It is, all I can say it is possible. We have done it because there's a number of so here's an example, right? So Storm Bolt has a piece of code that's executing on a tuple at a time, and if you're talking about hundreds of thousands of events per second coming in, you obviously have multiple instances of that Storm Bolt. Whereas in the case of Spark streaming, you have an RDD, and you will create RDDs with the incoming stream and apply map and reduce and filter functions on top of those. So both of those are possible. Essentially, you create that workflow, and we take care of the detailed abstraction, detailed application of that abstraction into creating a Spark streaming job versus a Storm topology. And there's a number of different use cases. It is definitely not a simple problem to solve, obviously, and that is the reason why we are staking our claim on that piece. And I think it's a very important differentiator for us. It's a very important value add for enterprises to be able to abstract multiple platforms. There's a question here about what tools do you see as competitors to StreamAnalytix? And do you have comparison of features between StreamAnalytix and competitors available for review? Yes, we see multiple competitors to StreamAnalytix. There are a number. I wouldn't mention the names here. I think you've addressed that in your question itself. And we do offer comparison features, comparison matrix, etc. We can offer that to you in private if you want. But the key thing is, I think what's emerging is that there are streaming engines such as Spark streaming and Spark and Storm and potentially Heron and Flink, etc. coming up. We think that the innovation process will continue, and as an enterprise, you need something that will have you be able to be successful immediately today at scale and giving you the performance and giving you the operators that Mike talked about, giving you all of the functionality at production grade elastic scale today, and not let you be blindsided next year when something else comes out which is 10 times faster. So that's what we would deliver with StreamAnalytix. So it is a little past 1 hour, Pankaj. Over to you to close the call.
Thank you, Anand. So thank you very much to the entire audience that has joined us today. I just opened up another rating and feedback poll. I request our audience to respond to that poll with a rating of your experience with the webinar today, and you can also provide a quick feedback or any comments that you may have. Once again, thank you very much for joining us. We welcome your feedback and ratings, and thank you very much, Mike and Anand, for the valuable insights. Thank you very much. It was a great webinar. Thank you.